All right, so this is another slide that I didn't originally have in here, so you'll notice there's no slide number, but I just created this slide because I thought it would be useful. So notice what the three-phase generator actually is. It is literally just 3 voltage sources referenced to this common neutral point, N, right? This is the common neutral point. And so the first voltage source is this VAN here, right? We're looking at the voltage between A, right, VA, and V, and the voltage of the neutral. Okay, so the line, the N line is called the neutral line. I talked about this a little bit previously. That's the first voltage, VAN. Oops. The first voltage. Oh no. Why is it taking the whole thing? Oh, I probably have to deselect images. Okay, good. So VAN is right there, and let's label this in blue. Color. And so that that source VAN would produce this sinusoid right here. Forget the rest of the stuff for now, the rest of the sine waves, but that is going to be produced by VAN. Okay, so that's one voltage source, right? If we were to take the rest of the stuff away, right, if we were to just scribble the rest of this stuff out, all we would have is this blue sine wave. And if we don't look at B or C right now, right, all we have is this right here. It's just a standard voltage source, a standard sinusoidal source that's outputting a sine wave, and that's all we're looking at. Now we add in another source, VBN, which is going to take the voltage between VB and VN, right? And that source is phase shifted by 120 degrees. And so if I draw in the green, that's going to be my VBN sine wave, right? I can probably fill it in even a little bit more, like that. Okay? And so that's VBN right there. It's just another sine wave that's 120 degrees phase shifted from my first sine wave, okay? That's VBN. What about VCN? That is the voltage between VC and the neutral, right? And that's just another source right here. That's another 120 degrees phase shifted. And so that's this one right here that I'm going to draw in the red. Okay. And if I were to continue this, it would be something like this. Okay. And so this is what a three-phase generator does. It generates 3 different sinusoidal signals, all referenced back to this neutral line, right? VA to neutral, VB to neutral, and VC to neutral. And it generates them, and they're independent of one another, right? They're dependent in the fact that they're 120 degrees phase shifted, so they're dependent in some way, but one voltage does not affect the other voltages, right? This is the sinusoid created by this source. This is the sinusoid created by this source. And this is the sinusoid created by this source. So if I were to build this in LT-Spice, and I will do that in future videos, I will build it in LT-Spice to show you, and I were to just delete these 2 sources, all I would have is just a standard sine source, and all I would see is just a single sine wave. If I were to build just VBN with the 120 degree phase shift, all I would see is this green source. If I were to build just VCN, I would just see this red signal, okay? So hopefully that's clear. The question is still probably, why do we do this and why do we care about this? And I'm going to get there right after this video. I'm going to cover why we use 3-phase power and why this is the way that signals are generated and transmitted commercially. Okay, so those are our 3 signals. I want to show a couple more slides here on the 3-phase generator. So the first thing I showed here was just the schematic of the 3-phase generator. It could be drawn a couple different ways, right? I don't need to draw it the way that they drew it there, but they draw it that way for a reason. You could just draw it like this if you really want. Also, there's no reason to draw them with pluses and minuses. They're AC signals. I don't know why the book feels the need to do that. Maybe whoever made the figures just didn't have a a signal source with a sinusoid symbol on it available to them. But we could call this the neutral. We could call this VA, we could call this VB, and we could call this VC. And this would be the exact same thing, right? This is the identical circuit or generator. This would be VAN, VBN, and VCN. And I've just drawn it differently. It's literally just three sources that are all referenced to the same point, which we're going to call the neutral, okay? And so the next slide, I just show, kind of what I already showed, which is that we could represent these three sinusoids by three different phasors that are basically rotating at some frequency, omega being the angular frequency, so this would be in radians per second. And if we trace the Y value, right, of VAN as we sweep this in a circle, then we would create this sinusoid. If we were to trace the Y value of this VCN signal, we would get this sinusoid. And if we were to trace the Y value of VBN, we would get this sinusoid. And so that's just, the phasor representation of how, we can view this plot in terms of omega t, and how we can, translate that over to a rotating vector, which we've seen in the past, okay? And lastly, I want to just show what the three-phase generator actually is. And so in real life, when things are spinning around in a circle, this is a magnet. This is another figure from the textbook. A lot of these figures I'm taking are from the textbook. And so this is a magnet with a north pole and a south pole. And when this magnet rotates in a circle, that magnet rotating past some electrical conductors, it will give rise to voltages, right? That is something you probably learned in physics. If you haven't learned that yet, the fact is that a time-varying magnetic field gives rise to a time-varying electrical current. And so when you look at a windmill, or when water is rushing at some kind of a power plant, or steam is being used to turn some kind of a generator, this is what's happening on the inside. Is it's a magnet that's actually rotating around. And as the north pole of this magnet aligns itself with one of these pairs of conductors, we can generate a sinusoidal signal, a sinusoidal electrical signal. And that is what is happening here. This is the electrical schematic representation of what a real generator does. And so it's important for us to keep in mind, really all that's important for us to keep in mind is that this circuit here produces these signals. But practically what's happening is some magnet somewhere is rotating and generating these signals. And this is the kind of, this is how power is generated and transmitted to your house, to industrial plazas and things that need power, etc. Okay, so we've talked about the three-phase generator. In the next video, I'm going to talk about why it is that we generate three-phase power in the first place. What are the reasons for generating and transmitting three-phase power? And from that point forward, we'll start talking about different types of three-phase sources, different types of three-phase loads, and we'll start analyzing these circuits, all right? So I'm going to go ahead and end this video, and we'll see you guys in the next video.